All right, we can find the sum of a sequence, and that actually has its own name. It's called the series. And we use, to denote series, we use summation notation. So we use this sigma here, where the bottom part, that's going to be like our lower limit. Like I think of it as like the starting point, and then you can kind of think about this 4 up here as the stopping point. So when I want to find this sum, I'm going to start with n equals 1. So 2 times 1 minus 3. And then I'm going to add that 2 and just hop to the next integer value for n. Well, let's plug in 2. 2 times 2 minus 3 plus, next, 2 times 3 minus 3 plus 2 times 4 minus 3. Stop. So pretty simple. Then we just got to simplify. 2 times 1 minus 3, negative 1. Plus 2 times 2 minus 3, positive 1. 2 times 3 minus 3, 3. And then 2 times 4 minus 3 is 5. So our final sum for the series is 8. What's really neat is we can also find the sum of an infinite sequence, but we can only do that if the sequence converges, meaning like the limit is going to approach a singular number, right? As n gets really, really big, well, we're not shooting off into infinity, but we're approaching one singular value. So looking at this one here, we know it converges, right? If you don't know what I mean by converges and diverges, please check out that video. Just kidding. Okay, anyway. Back on track. All right, we know this one converges because as n grows really big, we're going to have a really big number in the denominator, which means that this fraction is going to get super, super close to 0. It's basically going to be 0. So when figuring out what the sum of an infinite sequence is, I like to just start plugging in terms, right? We don't know what the starting point is, but maybe if we start, we can, start to see a pattern. So here I'm going to start, let's plug in 1. 3 over 10 to the first power. And then I'm going to add that to 3 over 10 to the second. And we can keep going. 3 over 10 to the third. And maybe we'll do one more. Normally, by the time you get to 4, you can definitely see a pattern. All right, 3 over 10 to the first, well, that's going to be 3/10. So 10ths place of a decimal, 0.3. Plus, well, 3/100ths, well, that's going to be in the hundredths place, so 0.03. Plus, right, you get the 0.1000ths now, 0.003. And you can probably already see a pattern. The next one's going to be 0.0003. When we add all of those together, we're just going to get 0.3333. And if we were to keep adding and keep going through the sequence, well, we would just keep adding 3's to the end. So this is 0.3333 repeating. And that's a really common decimal that we see. We know that equals, equals 1/3.